Alright, so this is the information that was retaught to Geometry Group A, or not Geometry Group A, Integrated Math Group A on Tuesday the 15th. So I'm going to go over that information with you. This document is also down below if you want some extra practice so that you're all getting the same information. So first, their pre-test results told me that they were struggling with solving equations. So we're going to talk about that. Let's start with number 2. Number 2 says negative 2m equals 8. Now solving an equation means we want to get that variable, the letter m, by itself. So we need to see what is happening to m. Well, with the content written right next to it, that number negative 2, that means multiplication is happening. So the opposite of multiplication is division. So we're going to divide by negative 2. And whatever you do to one side, you must do to your other. Now this goes away. And we have m is equal to negative 4. Okay, let's look at number 3. Now, number 3 is like number 2. You can do that one on your own. Number 4, we have negative 28 equals x minus 17. So our variable this time is x, and right now it's being subtracted by 17. So the opposite of a subtraction of 17 is an addition of 17. Remember, whatever you do to one side, you must do to the other, leaving us with x is equal to negative 11. Right, next I want to look at number 5 with you. This one says 18 is equal to n divided by 15. So we want to do the opposite again. The opposite of division is multiplication. So we're going to multiply 15 on both sides. Now this cancels out, leaving us with n equals 270. Make sure you are using a calculator to help you, especially with positives and negatives going on. Next one I want to look at is number 9, because sometimes when you want to solve for a variable, you have to simplify the equation first. So the first thing I notice is that we have this right here going on. It says 5 times 5a plus 2. This is where we use the distributive property. This means we're going to take what's outside our parentheses, our 5, and multiply everything inside by that number. So now we have 141 equals 6 plus 25a plus 10. Okay? Now, we're still not to where we can start doing our opposite operations to solve for a. We need to still combine like terms. For instance, 6 and 10 are considered like terms because they're both constants, which means they don't contain a letter or a variable, okay? So that leaves us with 141 equals 16 plus 25a. Now, to get a by itself, we want to go whatever's farthest away from a and do its opposite. So between the 16 and 25, who are over here with a, 16 is the farthest away. So we're going to subtract 16, because that's a positive 16, first, leaving us with 125 equals 25a. Now remember, if it's written right next to it, we're going to divide to get rid of it. So now we're going to divide by 25, leaving us with a equals 5. All right, let's see what else I went over with that. Aha. I went over solving a system using substitution. Okay, so the first thing you want to do is you want to look for the equation that says y equals something. So that would be this one right here in number 17. So what this means is in the other equation, if there's a y, we're going to plug in its place 6x minus 17. So this top equation now is going to turn into negative 3x minus 8. And instead of y, we're going to plug in 6x minus 17 equals negative 17. And just like with the problem we just worked, we have to simplify before we can solve. We have this negative 8 right here, right outside that set of parentheses. So we're going to distribute, as in multiply that negative 8 by everything inside our parentheses. Please have a calculator handy to help you with these problems. So now we have negative 3x minus 48x plus 136 equals negative 17. And just like before, we have to simplify some more. If we have like terms, we need to go ahead and combine them. I notice right here, these are like terms because they both have an x. So negative 3x minus 48x gives us a negative 51x plus 136 equals negative 17. Now we can solve for x. Again, we want to see what is farthest away from x. Negative 51 or 136. 136 farthest away. So we're going to do the opposite. Whatever you do to one side, you must do to the other. All right, now we still have that negative 51x. Remember, if it's written right next to the variable, as in there's nothing going on in between them, we're going to divide, leaving us with x equals 3. So before I even continue on with this problem, I'm going to see if I can go ahead and find my answer. Remember that a point is written as x comma y. So what I'm looking for in these multiple choice questions is, do I have an x of 3? All right, so this one says x is negative 2, so that doesn't count. This one says x is negative 3, so nope. This one says x is negative 3, nope. But this one says x is 3, and it's the only one. So that is our final answer. Now let's say we had more than one that said x equals 3. What you'll do is you'll take your 3 for x and plug it in right here to solve for y. So for example, we would say y equals 6 times 3 minus 17. Which would give us 18 minus 17, which gives us y equals 1. Okay? All right, next example I want to do for you is an example that I did with them about the elimination method. So the elimination method means that we are eliminating one of our variables. So we want to look to see if we want to eliminate x or y. So we're going to go ahead and eliminate x. So for us to eliminate x, we need for this to cancel out. So we have a negative 10x and a positive 5x. Well, if we turn this into a positive 10x, they'll cancel out. Well, how do we do that? Well, to turn 5 into 10, we multiply by 2. Whatever you do to that number, you're going to do to the entire equation. So here we go. We still have negative 10x minus 4y equals negative 30 on top. On the bottom, we now have 10x plus 4y equals positive 30. Ooh, I noticed something. You notice how not only do these cancel out, but these also cancel out, leaving us with 0 equals, and these also cancel out. Well, when it's 0 equals 0, that means we have infinitely many solutions. I would like to do one that isn't infinitely many solutions for you. So let's go ahead and look at number 26 as well. So let's see which will be the easiest to get rid of. For x, we have a 5x and a negative 9x. They cannot easily be manipulated. For y, we have a 5y and a 10y. Those can be easily manipulated because we know we can turn 5 into a 10 by multiplying it by 2. But now it needs to turn into a negative 10 because that one's positive. We need them to be opposite. So we're just going to multiply by negative 2. So now we have negative 10x minus 10y equals positive 10. And our bottom equation stays the same. All right, so let's eliminate. So negative 10x minus 9x gives us negative 19x. This gets eliminated, equals 38. Okay, let's go ahead and solve for x. We already know if it's right next to the variable, we divide. So we get x equals negative 2. So let's see. Looks like A is going to be our answer because it is the one that has x for negative 2. If you're like, well, how do we find y for this one? Again, you just take your x variable, plug it into one of the equations, and solve for y. All right, next question we worked on together as a class. We worked on solving systems by graphing. So remember, these are, you're really lucky, they're written in what we call point-slope form, or no, slope-intercept form. Y equals mx plus b. So you're looking at this constant at the end. This is where you plot on the y-axis. And then you're looking for whatever's in front of x to tell you where you're going to go from there, your rise over run. Okay? So starting with our top equation here, our constant at the end is negative 2. So my first point is going to be at negative 2. What's in front of my x? Well, it's a 1. That would be a 1 over 1. So I'm going to go up 1 and over 1 and plot my next point. So here is my first line, right there. Now for my next line, it's going to start at positive 2. and its slope is going to be -3 over 1. If you're like, where are you getting that over 1 from? Well, you have to make it a fraction. And if you have what we call a whole number, to turn it into a fraction, just put it over 1. So this means we're going to go down 3 because that's negative. 1, 2, 3, and then over 1. Ding. So here is our next line. Wherever they intersect, this is your answer. So our answer here is at +1, -1. All right, so if you notice, right here in the middle, about page 6, there are answers for that first set of problems. Now the next thing we talked about was our exponent rules. So let's review those. So first we have products. If we're multiplying, we add our exponents. What about if we're dividing? We're going to subtract our exponents. What if we have multiplication to a power? I tell my students to think of it as distributing. You're going to distribute to each one of them inside. What if you have division to a power? Again, think of it as distributing, taking it to each one of them. What if you have a power to a power? Okay, you're going to multiply. What if you have a power of 0? Well, it's always going to be 1 no matter what. And what if you have a negative power? To make it positive, you flip. Like so. All right, so let's do a couple of problems together. Let's look at number 21. So this is a product. So the first thing we need to do is take care of our numbers 3 and 4. So 3 times 4 is 12. Our variable is n. Now we look at our exponents and add them. 3 plus 4 is 7. Just like that. Okay, next we're going to look at number 29. This one is division. So the first thing I notice here is that we have n cubed, both top and bottom. Guess what they do? Cancel out, and you're left with 5 over 3. Okay, then we're going to go to 37. All right, first this is combining two different rules. First, the multiplication to a power. That means that this is going to go to everything inside. So we have 4 to the third and r to the third to the third. What do we do with a power to a power? We multiply. So 3 times 3 is 9. 4 times 3 is 64, r to the 9th. Okay, I want to do 2 more with you. 52. All right, all of this is going on in here, but what I notice is everything is raised to a 0 power, and anything raised to a 0 power equals 1. And then the last one I want to do with you is number 57. Again, this is combining multiple rules. First, we have our product to a power. So everything is going to get raised to this second power. So we have -3 squared, and we have m to the -3 squared. All right, so -3 times -3 is 9. -3 times 2 is -6. But we can't have a negative power. Remember, we flip to make it positive. So now it is 9 over m to the 6th, like so. All right, the answers again are at the end of this one as well. Please use that wisely.